Okay, my name is Clinton Keith, and this webinar is called An Introduction to Agile Game Development with Scrum, XP, and Lean. First, just want to introduce myself. My name is Clinton Keith. I was a video game developer for about 14 years. And back in 2003, we started using Scrum, and then XP, and then Lean at my company at High Moon Studios. And I started talking about Scrum at GDC in 2005. And enjoyed talking about it quite a bit, so much in fact that I decided to become an independent coach and consultant back 2 years ago. And so now I spend all my time traveling to different studios, helping them adopt Agile practices like Scrum, like XP, like Lean. And so I wanted to really talk to you today, kind of introduce what Agile is about, what Scrum is about, and what are the benefits of using Agile and what it does and what it doesn't do for you. Okay, so today what I'm going to do is start by just describing what is Agile. What are we saying when we talk about an Agile methodology, and how does that relate to Scrum and XP, and why should we use it? Second thing I want to talk about is just an overview of Scrum, very brief description of how Scrum works at the top level and what it looks like. I want to talk about Agile planning, which to many sounds like an oxymoron. Is that, well, Agile means you don't plan, right? And that's really not the case. We're going to talk about what planning on an Agile project looks like and how that's different from traditional project management planning practices. Talk about lean game production very briefly. A lot of companies that have been using Scrum have either been modifying it or even abandoning it during production. And Lean is an answer to some of the issues that teams run into using Scrum in production. We're going to talk a little bit about that. I want to talk about the expectations of Scrum in Agile, and more specifically, what you can't do with it, what problems it won't solve for you. And we'll leave a little bit of time, a lot of time, I think, for Q&A at the end. Okay, let's get started. So let's talk about what is Agile. Put most simply, Agile is an approach for developing products using very short iterations and using the result of each iteration, the output of each iteration, to adjust the project plan. So we have a plan out there and we're just adjusting that with each iteration, usually just a tiny little bit. Each iteration itself is like a short project. This means that we're doing a little bit of design, we're doing a little bit of coding, a little bit of asset creation, and a little bit of tuning and debugging. All those things that occur over the entire course of the project we're doing in each iteration. Uses an inspect and adapt practice to adjust those goals and measure progress. Scrum is called, or most Agile methodologies are called empirical systems, or a system that allows you to kind of look at your velocity and look at what you're doing, kind of like a speedometer on a car, and tune how you drive or how you're going on the project. We use the phrase inspect and adapt quite a bit on Scrum. So Agile starts with the Agile Manifesto. And the Agile Manifesto was created in 2001 by all these people that were talking about various methodologies that used a kind of an inspect and adapt process. And they basically got together and described, well, what are the overall values which describe all of our methodologies? And they came up with the term Agile, and they came up with 4 values which are used to describe Agile methodologies, whether they're Agile or not. And these values basically say the things on the left side are valued more than the things on the right side, but we don't abandon the things on the right side. So for example, we value people and communication over process and tools. Which isn't to say we're abandoning process and tools, it just says that, especially on a cross-discipline team which you're trying to create, that face-to-face conversation, face-to-face solutions are going to trump some of the processes and tools we have out there. So an animator solving a problem with an animation programmer face-to-face on a day-to-day basis is valued more than trying to predict and solve all those problems under, say, a Microsoft project. Second value is we value a working game over design documentation. Again, this is misinterpreted to say that Agile says we don't do any documentation. It's not true. We do plan. But it just says that working game is going to be more truthful. It's going to tell you more than a design document that goes too far, that tries to create too many details up front. So we're gonna use the both of them, but in many cases the working game is going to tell us a little bit more than what a design document can tell us about the game a year from now. We value customer collaboration over contract negotiation, especially these days when publishers are risking $30 million on a single idea, on a single game. That we want to have more collaboration with publishers. We want to explore things, especially in pre-production, and have things a little bit more flexible than a contract that says, hey, this is exactly what you're going to have running in the game 18 months from now, or we're not going to pay you. And the industry keeps learning again and again that that's not working. And the final value is that we want to respond to change over following a plan. Again, we're not abandoning all planning. It just means that there's things that are going to emerge that are going to be more fun than what we planned for them. And we might double down on those things. We want the opportunity to double down on those things. There's going to be ideas that come up over the course of the project that weren't considered at the start. We want to be able to take advantage of those. There's going to be things that weren't as fun as we thought. And we want to be able to drop them, have the opportunity to say, hey, let's not do so much of that. So the details of these values and some more principles are located on the Agile Manifesto website listed at the bottom here. So the question is, why adopt Agile? Why are we changing methodologies? There's really two reasons for it. The first is that we want to reduce wasted effort. We want to reduce crunch. We want to not postpone all the knowledge of what's fun to post alpha and go crazy at the end. We don't want to discover at the end of production that, hey, what we thought was going to take 6 months is going to take a year. We want those empirical measures all along that show us our velocity and allow us to make decisions about where the project is headed throughout the project by having the working game tell us where we are and eliminate some of these death marches that a compressed schedule can lead us into, or a schedule that surprises us at the end. The other thing is to really find the fun first, is to really explore the value of the game as quickly as possible. Again, we don't want to discover what the game is at the end of the project when it runs at 20 frames or 30 frames a second for the very first time, when the player can work with or see running AI for the very first time, all tuned and polished. We want to mix some of those things up throughout the project so that we see what the value is early. It's about prioritizing the work and getting things more done earlier in the project. I have this kind of graph that kind of illustrates what we're talking about with finding the fun first. You can imagine on the left-hand side, we kind of look back on a project and say, when did we know what the game was? When did we know how fun it was? And on an Agile project, what we're trying to do is follow this ideal, to say find the fun first. Focus on the things that are going to make the biggest difference in the game, and focus on the things which are going to give us the greatest risk. Focus on creating knowledge about what we're creating from the player's point of view. What does the player want to see? As opposed to, I think of more of a waterfall, or a project that does most of its planning up front and most of its tuning and debugging at the end of the project. The curve looks like this, and I kind of thought of some past projects. Initially, design does create a lot of knowledge about the game. It says, oh, we're doing a first-person shooter and not an RPG. We're kind of narrowing in on some of these things. But many times we go too far, and we give too many details. We predict too many details in our design document and kind of lead us down a wrong path. And then things kind of stay at a low level as everyone's working on their own section until we get these integration points like E3. E3 was a lot of work and a lot of hacking to get a build in there, but at least it caused us to focus on providing value, that people outside the project, people outside the publisher, were going to see this game by the thousands, and so we had to polish it. We had to kind of get a mini alpha beta in there to get something out to the public. Unfortunately, there's a lot of crunch in doing that and a lot of hacking that took us months to recover from. But in reality, what happens is that you really don't see the value of the game until the end of the project many times. When we optimize, when we debug, again, when it gets to the proper frame rate, when all the assets come into place and you start tuning everything and polishing everything, and then you get the highest slope of your curve of discovering the fun on the end of the project, exactly where you don't want it, when you're running out of time and you're running out of budget. And I don't know how many of you have been on a project at the end where you think, wow, I just wish we just had a couple more months. We could make this game twice as good. In reality, yeah, you're in the the highest growth of value on the project over on the right-hand side there. And so we want to get away from that model. Now, when we talk about Agile, I keep going back to this diagram here, which was created by Ralph Stacey in the mid-'80s. And what this diagram says is that based on your certainty of what the technology can do, and based on your agreement about what the requirements are, in our case, what's fun about the game, based on where your project is at, it kind of leads you to the methodology that you choose. So, especially in game development, where our platforms change every several 4 or 5 years, or if you're doing iPhone development, it seems to change every year, that we're far from certainty in technology. Even if we stay on the same platform for several years, our technology we want to develop and surprise the player with is going to create a lot of uncertainty. And same thing with requirements. We may think we know a lot about the game up front, and because we write a big document, but in many cases we don't. I don't know if you've ever gone back and compared the original design document with the game that was actually shipped, and you really understand that if you do that, maybe the only thing that didn't change was the title of the document. So it really shows that we're far from agreement at the start of a project. And what that leads us to is that our project is where that red star is. It's in the complex region. And what we do is a lot of times we plan things for the simple reason, the simple area of the graph right here, which doesn't belong. And our area of the graph is the Scrum area. This is where Scrum is best, when there's a lot of uncertainty about the technology, a lot of discovery that has to go on about the requirements. And we iterate and we increment towards the origin of this graph. And we never get there. I mean, a lot of products that are made in the world outside of game development sit near that origin. I could call this the Big Mac origin. This is where products that you make billions of, like Big Macs, sit. I mean, Big Mac has a 300-page design document, and because they have a lot of certainty about what it takes to make a Big Mac, and that 300-page design document says all sorts of things about the sesame seeds, about the bun. They've made billions of them. They can do this. This is why anywhere you go in the world and buy a Big Mac, it's going to taste exactly the same. We're never going to be in that region. We're always going to be in this complicated or complex region, and this is where Agile methodologies reside. So we talk about reducing waste. What we're talking about is we want to discover what works before we mass produce it, especially in pre-production. We want to find out what's fun before we make 12 hours of it. We want to discover as much as possible. We want to, as much as possible, not postpone value, and postpone debugging, and postpone optimization. As much as possible. We're not going to avoid all optimization and debugging at the end, but we're going to mix more of that into the middle of the project so that we know what the value is. For example, we don't want our games running at 10 frames per second throughout the entire project. That prevents us from understanding what's fun about the game. We want value, risk, cost, and knowledge to drive the order of what we work on, rather than a preordained schedule. Schedules, many times what they do is they try to optimize the resources, the people working on that, to say, okay, you animators go off and do 20 characters that we predict we need. You programmers go off and do these systems. And then somewhere later on, all these things will come together. What we want to do is mix that up as much as possible to prove our assumptions as much as possible in an iterative way. All right, so let's talk about a quick overview of Scrum. So Scrum starts with this product backlog, which is a prioritized list of features that we have in the game. So let's say we're doing a platformer, and we have, say, our features like jumping, crouching, swimming in the game. And once every iteration is called a sprint in Scrum, 2 to 4 weeks long, the team will go to this product backlog, and they'll basically choose things off of the top. They'll choose the features that are the highest value to the player, or address the greatest risk to the success of the game. In this case, this is jump. The person that prioritizes this list, we're going to talk about in a little bit, a product owner, says that jump is the most important thing to get in our game next. So the team takes that. If they have everyone available on the team to do jump, they'll break that down. They'll break the jump feature down into what's called a sprint backlog. A sprint backlog is a list of tasks that are estimated in hours, generally no more than 16 hours. And it's generally pretty highly accurate when they break things down to this level of detail. So once a team feels that they've filled up this bucket of work that they can accomplish over this next 2 to 4 weeks, which is based on what they've been able to do in past sprints, they'll commit to that goal. They'll say, yes, we can get jump. Maybe there's the other features down the list like crouch, but in this case, for example, they say, hey, jump is going to fill up this bucket of available time that we have, and we're going to commit to that over the next 2 to 4 weeks of our sprint. Now, they also meet on a day-to-day basis in what's called a daily scrum to really kind of review their progress towards their goal of getting jump in the game. Okay, what are the problems that we're having getting jump on today? What are we working on next? What have I accomplished over the last 24 hours since we last met? Then at the end of the sprint, they produce an incrementally improved game. It's a new version of this platformer game with jump in it. This is where things change a little bit. Say the product owner, we get jump in the game, and it's a huge success. And the product owner says, oh, I want more features with flying in the game. Let's double down on this in-air thing. So we can make a decision like putting, say, flying in the game. Maybe the character can sprout wings like Mario can and have an extended jump for maybe 10 or 20 seconds. And we can reprioritize fly to say, well, it's not as important as crouch, but it's probably more important than swimming. So let's modify the plan a little bit, reprioritize the work based on this working game that we're seeing. We're modifying the plan based on the working game. Now I want to talk about the who's involved in a Scrum project, what are the titles, what are the roles. Now you have the team itself, and the team is generally a cross-discipline team that consists of everyone necessary to get that product increment like jump into the game. So in this case, I mentioned we need an animator, obviously, for jumping. Programmers, artists to do character models, designer in there to give us feedback about the look and feel of jump, the controls for it, and even somebody from QA to make sure that that jump is working across all sorts of different environments and different platforms if necessary. We have the Scrum Master, and generally also a member of the team. Not necessarily, it's not an authority role. It's somebody that's facilitating the team, that's helping them remove all their impediments, clearing the path for problems from the team, and making sure that the team is following the rules that they've set up for themselves, which include these basic Scrum rules we'll talk about a little bit. We have the product owner. And on large projects, you can have many product owners, but there's usually one lead product owner. It's usually like an internal director, maybe a lead game designer, who is really representing the customer and the stakeholders out there and helping to prioritize the project. He's responsible for the progress of the project and the return on investment, that they're kind of exchanging the money that's spent on every sprint by having the most important features, the most valuable features to the customers and stakeholders being implemented in the game. So some of the key principles of Scrum is that first, we always deliver. The sprint ends on a fixed time. It's a time box. If we say the sprint ends on a Friday, it always ends on the Friday. It never ends on the Thursday. It never ends on the Monday. What we want to do is essentially create commitment by creating this sacred deadline. Now the functionality may vary, and we'll talk a little bit about this. Sometimes teams overcommit, sometimes teams undercommit. But we want to give them a little sense of ownership to say that, yeah, you've committed to this, we're not going to change the dates, and you can't change them either. What we're trying to do is to create a reciprocal commitment between the business and the team. The team commits to delivering some amount of functionality, and the business commits to leave those priorities alone during the sprint. We're not going to come in halfway through the sprint and say, hey, we changed our mind about the jump. We want you to do jumping and swimming because we just thought of it or this new deadline came up. Because if you do that, if you can come in and disrupt the team, then they're not going to get a sense of ownership. And this is a very powerful part of Scrum, is to create these iterations of ownership so that the team can feel like, hey, we're controlling our own destiny, even if it's just for 2 weeks. And when you create this sense of ownership, you get all sorts of other great behaviors. And this is where Again, this is where the huge benefit of Scrum comes from, is that sense of ownership, sense of commitment from the team. And they treat their work differently when they have just that little bit of sense of ownership. And you can think about how you might treat a house you own versus a rental house. I'm not saying you destroy a rental house, but say, for example, you find a leak in the wall of your house that you own one morning. Well, if you own the house, you're going to call in and say, hey, I got to take care of this leak. I'm not coming in. Maybe after lunch, and you're going to be on the phone calling a plumber. It's going to be an emergency situation for you. If you're a renter, you're not going to act the same. You're not going to skip work. If you're a good renter, you're going to call your landlord and say, hey, I'll let you know you got a problem you need to take care of, and I'm going to work. See you later. We get that same difference in behavior from people on teams that have different senses of ownership. One of the artifacts of Scrum is a task board that shows, it's kind of what's called an information radiator. It's something that can be in a separate war room or among the team, but it represents the work that's being done on a day-to-day basis by the team. So you have on the left-hand side the what's called user stories. Those are those prioritized features like jumping and crouching and swimming that the team commits to. And they commit to that, as I said, by breaking down the tasks that are in that big middle area called the sprint backlog. And as tasks are accomplished, they get moved over to the right. Things are in progress or things are pending approval, or completed tasks go all the way over to the right-hand side. I also want to point out this piece of paper here near the bottom. It's called the Burndown chart. Now, that's part of our empirical process model with Scrum that says that it shows on a day-to-day basis the velocity of the team, where the team is at in regards to that commitment that they've made at the beginning of the sprint. I want to show that in a little bit more detail. So say we have the team commits to a number of hours. Let's say they commit to 600 hours. It's a team of 8 for a 4-week sprint. And they said, well, we can usually finish about 600 hours of work over this course of 4 weeks. And that's based on a velocity that the team has discovered. Many teams discover that they can only get 4 or 5 hours of real estimated work done on a day-to-day basis. Things like bugs come up, interruptions come up, all sorts of things that are overhead of work, communication overhead. If the team's split up across multiple rooms, that has a significant impact on the speed at which they can finish these features. So the team starts with, say, 600 hours. In some cases, when they start on that work, they discover things right away. They discover that we ran into problems, or the build is broken, or this one task that we thought was 10 hours turned out to be 5 tasks of 10 hours. And so sometimes you'll see situations emerging like that at the beginning of the sprint. The nice thing about this burn down is that shows that immediately. And it allows the team to react to that. Sometimes on a day-to-day basis, it's something to talk about. Hey, why is this going up? What are the problems? Sometimes it goes flat, which means maybe the build is broken, or maybe there's another team that's holding us up or throwing problems at us. The key thing is to get those issues out of the way as quickly as possible. Then over the course of the sprint, teams will usually get into a fairly steady state of accomplishing that maybe 4 or 5 hours of work per person per day. It's also a useful measure to kind of forecast where we're going. So we use that to say, hey, look at the slope of that curve and predict where it's going. And that slope shows the velocity. I said maybe 4 or 5 hours a day. Now this kind of exposes a great deal of the value of Scrum. And that's that Scrum is not a methodology. It doesn't tell programmers how to program. It doesn't tell artists how to create art. It doesn't tell designers how to design. It's a framework for those things, for you to build your own process, to find out how to add or remove or change processes that gives you that empirical feedback. So in this case, we have this velocity that's a slope. And I'd say for one example, teams that are spread across the building will have a much more shallow velocity than teams that are co-located in the same room. So the team can decide, hey, let's move it together in a room and see what that does. And that slope should increase. We should get more work done per day because we've removed a lot of the overhead of communication. And there's many practices like that that the team accomplishes or changes on a sprint-to-sprint basis. One practice that teams do is they have a retrospective. It's kind of like a post-mortem at the end of a sprint, where they discuss things that they want to start doing or stop doing or recognize things that are working because they've had an impact on this empirical measurement. I said it's like a speedometer in a car. You try something and it's either going to apply the gas or apply the brakes. And you should be able to, if you can see the result of that change immediately, then it tells you whether that was a good change or not, which is critical. Drag are things that work against that, like having a really buggy build. Bugs create drag because you need to fix those problems. We can't get the latest build because it's broken. But we can also use that slope to forecast where we're going to be 2 weeks from now or 3 weeks from now. And in this case, because of the problems at the beginning of the sprint, the team sees that they're going to have about 150 hours left. Now, the initial impulse of the team is to say, well, can we make up that time? Teams can decide, hey, we're going to do a few evening hours throughout the week. Our company, we banned people from coming in over the weekend because we saw the impact of velocity of people just burning out. But in this case, the team will say, 150 hours of makeup between now and then is just too much. And we don't want to punish them for not foreseeing problems. In many cases, these problems aren't their fault. And so what we'll do is we'll take a look at that. And we said, again, that cardinal rule. We're not going to extend the sprint. The sprint must hit 0 hours at the end. So what we're going to do is we're going to have a conversation with the product owner and say, we're going to take maybe the 1 or 2 of the least important stories on that backlog for the sprint, and we're going to remove them. We're going to take them off this sprint backlog. And that might get us 100 hours off, but the team's going to take a look at it and say, yeah, we can work a few evening hours, but with this we're going to get close enough, maybe 30, 40 hours within, and we can certainly work extra hours to get caught up with that. Because we did say we can commit this stuff, and teams don't like to fail to achieve all their goals. And so, the team hit 0 hours at the end, and dropped a few stories. So they have a conversation that needs to take place. And hey, why did we get into this situation? What do we need to change to avoid that in the future? Sometimes there is no answer. Sometimes things crop up that you can't anticipate, even over 2 to 4 weeks of time. A question comes up is that Scrum teams need to be about 7 to 9 people ideally. Once you go above 10 people, communication starts to break down. But very few games these days can be made. Maybe iPhone games can be made with that few people or fewer. A lot of console games, a lot of larger games require well over 100 people. So Scrum handles that by scaling. And one of the artifacts, one of the practices of scaling is called the Scrum of Scrums. And what this is kind of a meeting among representatives from each team that occurs on a day-to-day basis or a week-to-week basis, depending on what the project needs. So a representative from each team, and maybe somebody from functional leadership, like a CTO or executive producer, maybe somebody from support services get together, and they meet in this other meeting called the Scrum of Scrums. And they discuss what are the problems that are facing teams that they can't solve. What are some of the issues? So things like, well, on our team we need a new version of Maya, or we need a new animation tool that's holding us up. Well, that's something that the team can't solve themselves. They can't issue a purchase order, but in the Scrum of Scrums there should be somebody there that can address these problems on a day-to-day basis. And this is another strength of Scrum, is that we're creating this transparency to all these issues that come up, so that if somebody needs a new tool or needs to purchase a plug-in for Maya, well, that purchase order should go out as quickly as possible if it's approved, if we see the value of that. Because one of the kind of laws of project management, and this was identified by Fred Brooks, who wrote Mythical Man Month in the 60s, on one of the first big projects. He said that projects don't get a year late all of a sudden. You don't wake up one day on a project that's on schedule and discover, oh, something happened overnight, now we're a year late. What happens is you lose hours a day. You lose 3 hours a day or 2 hours a day because all these little problems that add up. Oh, the animators, they can't get their animations into the state machine because the state machine's broken. Well, we need a programmer to fix that. If we have to go through this hierarchical chain and insert a task to fix the state tree into a busy animator schedule, that might not be done for 2 weeks. Scrum allows that to be done on a day-to-day basis by focusing on what we're getting in the game, what's important to us to keep that velocity up high. Okay, so I want to talk very briefly about extreme programming. Extreme programming is something that we adopted at High Moon Studios. And basically what it is it stands extreme programming is an agile methodology which includes practices like test-driven development, and probably the most controversial practice out there that some XP developers do or don't use is called pair programming. Now, what test-driven development is that you surround the code that you write with individual tests that test the behavior of that code over time. And what this allows you to do is to check in changes very frequently with a high level of certainty that any problems that you introduce are going to be caught very quickly, and that any changes over time, by discovering how, that, hey, we want to change the camera manager, or we want to change the animation system, as we discover what's valuable and not, is that we're going to keep this cost of change curve really low, which is that green curve. Now, typically, the cost of change in code goes up over time. So we introduce a bug, and the cost of changing that bug is really low at first. Hey, I just wrote that code, I understand it. If I catch a bug with that, it's just maybe a few hours to fix that. If that bug is left in the code for months and months, then they've measured that the cost of fixing that problem can be as high as 10 or 20 times more expensive if you fix it months later. That's because maybe you've forgotten about the reasons why you wrote that code, or maybe somebody else has to fix it who didn't write the code, or maybe now there's hundreds of functions that depend on that buggy piece of software that was written, and fixing that causes more problems. It's kind of like removing rust off an old car, and it causes even more problems because the rust was holding things together. And so test-driven development allows that cost of change to remain very low, which is important, especially on agile projects, where we're not trying to predict all of our architectures up front. And the benefit of that is kind of captured here. This was from a spreadsheet that we had that showed we decided to measure the stability of our game over time. And we had some test servers out there that were running the game and playing the game through scripts, and would report the percentage of time that the game was crashing. Now, when we started doing this, it was crashing 75% of the time. It wouldn't finish playing the game. And we focused on getting these things improved using test-driven development. And after about a year, we got that stability up to 95%. This is an example of an empirical measure that shows things that you care about, that you can try things like test-driven development and see if that percentage goes higher. Because the problem with the build only working 25% of the time is that artists and designers and even programmers that want to put a change in the game, to try something out, to iterate on the game, are faced with the build being broken 75% of the time. And so that really impacts their velocity. Again, this is something that's very transparent. It shows that fixing bugs, getting the stability higher, has a huge impact on our team velocity. So one of the things I wanted to talk about very briefly was pair programming. Very controversial practice. Some use it, some don't. We used it, and we found out there were some benefits to it. Pair programming can be thought of as kind of a continuous peer review, or a continuous design discussion between two programmers who sit together with one computer, one screen. And the benefits of it is it promotes mentoring. Usually you have a senior programmer with a less experienced programmer paired up. Knowledge sharing about patterns and coding practices. Creates a consistent standard without standardization documents by splitting up pairs. And allows much improved resource sharing. So allows two programmers, any piece of code has two programmers that understand it. So you kind of avoid that problem with that mythical bus out there that's threatening to run over your most senior programmers or most talented programmers that everyone's afraid of. So there's always, or that programmer is overloaded at certain times of the project and can't fix that piece of code that they own. But we'd only pair under certain circumstances, and your mileage may vary. So we'd figure out basically we'd decide whether to pair based on the problem complexity and the experience of the programmers working on a piece of code. So if you had a low-level experience, like an entry-level programmer, we'd always pair up an entry-level programmer with somebody else. Again, it's the mentoring, the knowledge sharing. It brings them up to speed 2 to 3 times faster. We'd also always pair up if the problem complexity was high. So if we had to create an animation system or a physics system or something very complex, we'd have 2 senior programmers or 2 experienced programmers that would pair up and those constant design decisions would happen, which would really benefit things, benefit the creation of that software. But a good portion of it we wouldn't pair. You don't need to pair up to fix a bug. You don't need to pair up to maintain or tune or iterate on some gameplay mechanics all the time, especially if it's two experienced programmers. You just don't get the same benefit from it. So it's something that I recommend trying under certain circumstances, but you got to keep an eye on where it benefits. Don't just apply it and say, well, the rule says we have to do it, so we're going to do it. I like to be very flexible about the benefits of those rules. As long as you have those measurements that show you the benefit of trying different things, then you can be really flexible with these practices and try different things out, invent your own practices. Okay, so I want to talk about, that's it for XP, I want to talk about Agile planning. So we talk about Agile, a lot of people think it means we don't plan, that we're doing this, that we have some unknown goal in mind. We don't know what that goal is. And we're going to start somewhere, and what we're going to do is we're just going to wander around and, hey, let's discover what's fun here. Let's go over here. Oh, no, let's try this direction over here. No, that's the wrong direction. Let's go over here. And then finally, we'll arrive at some ending condition. That's, hey, we didn't know what we were going to make when we started, and we wound up with a third-person action adventure game. Now, teams that don't plan, teams that adopt Agile and say, hey, Agile means you don't plan, they do this. But that's what Agile planning is about. The philosophy of Agile planning, the difference between traditional planning, is that with traditional planning, what we're doing is we're saying, hey, we have a goal in mind. We want to be there in 2 years, and these are the steps that are going to take us to that goal, which is going to be a great game. And we basically say, okay, we're going to work for 2 years and hopefully get to that goal. Well, the problem is, even if you wind up at that goal on schedule and time, a lot of times you discover, hey, we need it to be over here. And this is, we go into crunch, we rush around, we try to cram things in. We're running out of budget and time. This is where we get into this death march. And what Agile planning says is that we got to acknowledge that the further out we plan, the less certain we truly can be. I mean, it's sad. I wish it weren't true, but it's just really the nature of planning is that, especially with 100 people, you just cannot predict out 2 years with a great deal of accuracy. In the short term, it's much more accurate. This is referred to as the cone of uncertainty, or some people call it the cone of certainty, that says that we can be pretty certain in the short term, but over time our uncertainty grows. What Agile planning does is just acknowledges that and says that, hey, what we want to do is we want to have that goal out there. We want to have the plan. And it could start as exactly the same as the traditional planning method. But what we're going to do is over time we're going to take steps. And as the game emerges, it's going to tell us, maybe we need to be over here. Maybe we need to alter the plan. And as you alter things slowly over time, you alter maybe 1% of the plan every iteration or half a percentage, then you're steering the course towards a better product. Ideally, as long as you have that game that's telling you. And it's the same with the practices for Scrum, is that on an iteration basis, you're not only discovering what you're making and iterating on what you're making, but you're iterating on how you're making it. You're trying to discover better ways of making it, practices that you can do to work better as a team and to get those improvements slowly, even if it's just 1% every iteration. It really adds up. I love this quote by Dwight Eisenhower, who was asked after World War II. He said, hey, did D-Day go according to plan? He's going, of course not. The D-Day plan was worthless as soon as the attack started. Yeah, the paratroopers landed all over the place where they weren't supposed to land. Look at the mess at Omaha. We failed to take this city. He said, but the plans were useless, but planning was everything. Planning created that knowledge. It allowed us to understand all the potential issues that could occur, create knowledge about the terrain, create knowledge about where we thought all the opposing forces were, so that we could alter that plan based on that knowledge that we created, but left some flexibility in it. To me, it's like climbing a mountain. You don't want a plan that shows you every single footstep up the mountain. You also don't want a plan that says, well, just go uphill, that's it. You want something in between that says, well, here's all the potential paths, and if weather comes in, maybe you can take this path, or if this avalanche blocks this path, here's another path that you could use. You know, we want kind of a mixture of planning and flexibility in there. And so we talked about that product backlog, which was those list of features that we wanted in the game. If you look at it like an entire scope of a project, of ideas of things you want in the game, and I'd like to think of it as an iceberg. So this iceberg is organized by priority, where the features on the top are the most detailed features. Those are the ones we plan out in a great deal of detail. We break them down to their smallest components that can each fit inside of a sprint or an iteration. Those are kind of like the snowballs on the top of the iceberg that every sprint you toss off. And then what you do is you break down some of the stories off of what's called a release plan, which is like a 3-month plan. And break those down and populate, fill up the sprint, or the next sprint goal that the team is going to break down and work on if they can accomplish all of that. So I want to talk a little bit about those releases. Those releases are 3-month major goals that the teams establish, and that's kind of their second planning horizon. The first planning horizon is the sprint. They break things down into tasks that are no more than 16 hours. The release is usually about 3 months. It's kind of like a milestone pace, where the team breaks things down into larger chunks that they estimate differently. And over the course of a project, you have a different set of releases. You might have like a concept or a green light release that lasts 3 months to get approval for pre-production. And then you might have 3 or 4 releases of each 3 months to explore what the game is, to discover what we're going to produce. And then you have a number of production releases. It might be a year long, depending on your game. And then some alpha and beta releases that now you're making sure you pass TRC, TCRs. Once all the levels come in off of production, you want to pace the entire game. You want to continue polishing and doing things that you couldn't do throughout the course of the project. So I want to talk about lean. Now, on the previous slide, I had identified that we're separating pre-production from production. And this is one of the challenges of game development, is that with Agile, we can't quite be purely Agile with game development. Is that Agile says, hey, every little iteration looks like an entire project. But that's not the case with us. We have this challenge with production that says, hey, we discover what the game is in pre-production, then we make 10 to 12 hours of content to flesh out that gameplay experience that we discovered. So rather than everything being balanced over the course of the entire project, we do more concept design up front. We do more asset creation and production towards the end. This is what kind of separates our pre-production from production, from the two really major stages that are significantly different from one another. And there's different approaches or different mindsets that we have about each one of those, and it impacts how we approach it in an Agile way, or even if we do use Agile for production. And this has kind of been emerging over the years as we've been using Agile in game development, this knowledge and how to deal with these two different stages. So when we think about pre-production and production, we've got to say, what are the questions that we're asking ourselves in each one of these stages? In pre-production, we're saying, hey, what's fun? Now, how are we going to build it? In production, we're saying, we just have to build 10 hours of it. We know what's fun. We just have to double down, and our staffs are going to increase. We're going to do outsourcing. We should know what's fun. What are our goals? In pre-production is correctness. What's fun? What's correct? We're going to throw things out as we discover whether they're correct or not, or change a few things. Can't do that so much in production. It's all about the efficiency, building it as fast as possible. States of mind. Pre-production is more about cross-discipline collaboration. Hey, let's iterate on that. Let's experiment with this. Let's try this out. It's less so. You still have collaboration in production, but it's more about flow, from what it takes for these assets to flow through production streams. The approach is different. We're more about iterating and incrementing during pre-production. I'll say with our platformer game, we're putting jump in, and we're looking at what the perfect jump height is. We're trying different jump heights. We're trying different ways of jumping. We're adding flying. But we're in production. Now we're making hundreds of ledges based on that jump height. So we don't want to change the jump height, because all of a sudden now we're creating a great deal of waste. We want to find out what the perfect jump height is in pre-production, and then just incrementally improve how we're making those assets, and incrementally improve things that are not going to destroy what we iterated in pre-production. So I'm going to go back to this curve right here, or this graph. We said pre-production, we're right here. This is kind of the Scrum area, uncertainty of technology. We don't have a lot of agreements about requirements. And then we're iterating a lot. We're discovering things. We're throwing some things out. We're saying, hey, try this. Let's iterate 5 times on this. It's okay to try different things and throw things out. But we are incrementally improving things. And then what we're doing is we're pushing on that technology certainty and discovering what those requirements are and going down closer to the origin. Now I can see in the graph on the bottom that we're far less iterative. And we're not throwing out the jump height. We can't, but we're more incremental. We're trying to find improvements and efficiencies. Now, really Scrum covers all this whole area, but teams have been discovering that you can apply some lean practices that are out there and adopt some of these in areas where Scrum kind of breaks down in creating those flows, in creating those highly incremental but lower iterative practices. So this is where it leads us to lean game production. And what lean game production is a translation of lean manufacturing principles and practices to video game asset production. That kind of worries people. They think, well, we're not an assembly line. You know, we're not factory workers. But what we do is we kind of look at lean manufacturing and learn how that they've kind of gone away from this robotic assembly approach of looking at ways that we can continually improve the production line while we're producing things. And so we want to apply some of those practices. And some of the philosophies introduced in lean manufacturing is what's called the Deming cycle, which was introduced back in around after World War II, the plan, do, check, act cycle, which says that, hey, we're going to always look at what we're doing and try to improve our efficiencies of how we're doing that. And that should sound pretty similar to the Scrum or Agile practices of inspect and adapt. Let's look at what we're doing and how we're doing it and try to find ways of improving that. So I don't have too much of a chance to go into lean. I'm going to give you a link to a white paper that talks quite a bit about that. But lean game production kind of looks at some of these asset streams, these long, complex streams of things that occur to say, let's do level production, which could be dozens of steps, which don't quite fit so cleanly into that time box, that strict time box of a sprint. It doesn't fit so well with Scrum task boards. And so we've introduced some practices like Kanban, which is shown below. That's a Kanban board. That kind of limits the flow or monitors the flow throughout this entire pipeline that lets us know on a day-to-day basis where there's problems with the flow and try to keep things as lean as possible. So I want to briefly talk about the 7 lean principles. That's eliminating waste. Say that was one of our goals at the start of this talk using Agile. We want to continually identify and eliminate waste. I want to amplify learning. We want to basically say, hey, if we schedule everything and we say everything, these levels have to roll off the line every month, and we're kind of fixing things in concrete. And what lean says is that, hey, we kind of start that way. We start with a plan, but we're always looking for ways to improve that, to kind of put pressure on getting things more efficient by looking at our practices, by looking at the knowledge of everyone on the line creating these assets, and look at ways of improving our knowledge about how to create these assets. Again, decide as late as possible. Kind of like the same idea of not documenting everything up front. We want to leave a certain level of flexibility. It's less in production than it is in pre-production, but still we don't want to build 12 characters and have them all waiting by the time the first character gets in the game, because that's the first character that gets in the game is usually going to tell us certain limitations that we weren't aware of, polygon count, bone count, things like that, or character control stuff. And we don't want to have this big debt of all these other characters to go back and either throw away or have to rework. We want to minimize that. And that is included delivering as fast as possible. If we have a big pipeline with 12 characters in it, it's going to take a long time for one character to be changed to go through that entire stream. We want to have that stream as thin as possible so that we can introduce changes into the stream that have an immediate impact. Again, we want to empower the team like Scrum. We want to give the team the opportunity to identify issues and improve their flow locally and give them a little bit of ownership. Build integrity in. We want to have developers that approach the problem from the player's point of view. I want artists to be game developers first. I want programmers and designers to be game developers first, and then be craftsmen second, to look at what the player needs and focus on that, and to see the whole. One of the big lean lessons is to say that if you optimize the whole, then you get a much better flow, much higher efficiencies than if you optimize individual parts. If you say, hey, you know, we have to get all these modelers creating characters ahead of time, so there's not people waiting around, there's not animators waiting around, and so that ends up with, you know, a dozen characters that are in various stages of development before the first character gets in the game, and winds up with that great deal of waste. So I'm going to give my website at the end. There's a link directly on the front page for a white paper about this stuff. So I want to talk about really what the realities are with adopting Scrum. Because I see one of the problems out there is that a lot of studios that adopt Scrum or Agile think that it really does more than it actually does. And so I want to be clear about, you know, what the myths are. First one is that Scrum is going to prevent problems or even solve them for you. And it's just not the case. What Scrum does is it exposes all the problems. I've heard it likened to your mother-in-law. Exposes all of your shortcomings. It's not going to solve them for you. I've seen studios that have adopted Scrum, and now you've given the ability to every person on the team on a day-to-day basis to report the things that are holding them up. And a lot of those things float up to the Scrum of Scrums and reaches management. And all of a sudden now they see hundreds and hundreds of problems being reported through this transparency. And unfortunately, sometimes what they do is they say, hey, look at all these problems that Scrum is creating. Let's stop doing this. And they stop doing it, and the transparency goes away because they anticipate that Scrum is going to solve the problems for them. It's not. It's going to expose these problems. Scrum can achieve impossible goals. I think the best thing, I've heard of projects that say, well, we've got 6 months to do this AAA game, and we don't have half the people we need. But we're going to use Scrum, so hallelujah. And in reality, it's not going to do miracles. At best, what it's going to do is show you, based on these empirical measurements of velocity and progress, that sooner than later you're going to know it's an impossible goal. And unfortunately, yeah, bad news sometimes is blamed on the messenger. The other thing here is that the idea that Scrum does not require competent leadership. It absolutely does. Scrum focuses the role of leadership. What it does is it takes a lot of the management off of the leader's plate. So if it's a leader that basically sits at their desk using Microsoft Project, has to really change their approach to how they lead. This focuses on more of a directed role of leadership and mentoring, of getting out on the floor on a day-to-day basis, even freeing up some of your time from spreadsheets to now actually doing a little bit of art on a day-to-day basis. See what individuals on the floor are really experiencing. It makes you a better leader. So just briefly want to just talk about adopting Agile. I had some challenges with adopting it. But one of the things that's been a success is having a beachhead team. Having a single team go in and adopt Agile and try it out and see the benefits of it and the cultural impact of, hey, this is how we work and this is the pressures that Scrum are putting on us. So for example, you go from a studio that has to deliver milestones every 3 months, which means their software really has to work every 3 months, to putting the pressure on them to delivering software every 2 weeks. That's going to break a lot of things. It's going to expose a lot of problems. So having a beachhead team out there trying things out and clearing the way for the other teams is very beneficial. recommend starting Scrum by the book. Use the practices. And the reason is that a lot of these practices don't make sense at first, like the daily Scrum. A lot of companies think that, or studios adopting this, they come from a task-oriented point of view. Now, tasks are extremely critical on Scrum, but the working game is even more important. We're focusing on delivering that working software and focusing on team commitments every 2 to 4 weeks. But teams that aren't used to those principles, they're more focused on delivering completed tasks, view the daily Scrum as just a task reporting exercise and say, hey, we can replace that with a web tool. Why do I have to get up from my desk for 15 minutes every day? And why can't I just have a web interface? And they do that, and they destroy a great deal of the benefit that they will eventually see from the daily Scrum, which is that peer commitment, which is that kind of like a football huddle of everyone getting together and saying, okay, this is our plan of attack for getting this, moving the game forward over the next 24 hours. A lot of teams, they have to work in an iterative development model like Scrum with a publisher that says, oh, we want spreadsheets, we want Microsoft project plans, we want big documents. And you can iterate against a plan. And you can, over time, build trust with the publisher or your stakeholder that says, I trust plans, I want details. And start to get a little bit of flexibility in there. And I got to throw a pitch in for myself and just say, there's coaches out there. We benefited from having a coach come in and help us out over various stages. It's something, again, you have to, studios take responsibility for their own process and growing their own process. But having a coach come in and help is, we saw it as a benefit, and also encouraged me to enter this career as well.